Hey everyone, and welcome. Today I want to show you something that is just, well, it's pure geometric magic. It's a puzzle that's over 100 years old, but it still seems to completely defy logic. Honestly, it's one of my all-time favorites. Let's dive in. So take a look at these two shapes. Over here on the left, you got a perfect square, and on the right, a perfect equilateral triangle. I mean, they couldn't look more different, right? But what if I told you that they're both made from the exact same four pieces? Nothing added, nothing taken away. And that's the big question, isn't it? How in the world can you take just four pieces and have them perfectly form a triangle and then perfectly form a square? It really feels like that shouldn't be possible. And here's the first twist that makes it even cooler. The pieces aren't loose. They're actually connected by these tiny, clever hinges. They form a chain that can literally swing and fold from one shape right into the other. But that just makes it even more mysterious, doesn't it? How do you figure out where to make those cuts in the first place? Well, to get to the bottom of that, we've got to meet the guy who came up with it, Henry Dewdney. He was this brilliant English mathematician, and you could argue one of the greatest puzzle makers who ever lived. So Dewdney first dropped this puzzle on the world back in 1902. A few years later, he even presented it to the Royal Society, the top scientific minds in Britain. He also put it out there as a public challenge in a national newspaper, and as you can probably guess, it totally stumped hundreds of readers who tried to solve it. I love how he described it in his own words. He called it a demonstration. It wasn't just a clever trick to him, it was this beautiful, logical proof that you could actually transform one fundamental shape into another just by cutting it up the right way. And this right here, this is his original drawing from more than a century ago. Yeah, I know, it looks a little intimidating with all those lines and letters, but don't worry. All the secrets are hidden right here in this diagram. Let's break down exactly how he did it. All right, so now let's pull back the curtain and see exactly how Dewdney pulled this off. We're going to walk through his genius method, and I promise, we'll make the seemingly complex geometry super simple and clear. Okay, so here's the game plan. It's basically a four-step process. We're going to find a couple of key points, then use a really clever arc to figure out the most important measurement of all, and then, with just two more simple lines, the four pieces will just appear. It's so elegant. Okay, here we go. We start with our equilateral triangle. The very first thing we do is find the exact middle of two of the sides. That gives us points D and E. Simple enough, right? Then we draw a straight line from corner A right through point E and just keep it going to create a new point, F. Now, get ready for the aha moment. This is the real magic. We find the midpoint of that long line we just drew, AF, and from there, we swing a big arc. You see where that arc hits the top of the triangle? That gives us point H. And here's the kicker. The distance from E to H is the precise side length of the square we're trying to make. It's just an incredible geometric shortcut. And once you have that, the rest is easy. It's all downhill from there. We use that newfound length to draw the line EJ. Then, all that's left to do is drop two lines at perfect right angles from points D and another point, K. And bam! Just like that, hidden right inside our triangle are the four magical pieces. So, we've seen how the cuts are made, but the bigger question is, why does it work so perfectly? That's where we get into the beautiful mathematics that are hiding just under the surface of all this. So, the whole idea here is based on a principle called geometric dissection. It's this whole field of math that's about the art of cutting up one shape into pieces that can be perfectly rearranged to form a different shape. And the golden rule, the one thing that has to be true is that the total area has to be exactly the same. You can't lose or gain any material. And that's why Dewdney's method is so ingenious. All of those steps we just walked through, the midpoints, the arc, they're not random. They are literally a visual proof. It's a way to find the side length of a square that has the exact same area as the triangle, but without doing any complex algebra. It's a proof you can see and touch. What's truly remarkable to me is that this puzzle, designed way back in 1902, isn't just some dusty historical artifact. It's actually more alive and relevant today than it has ever been. I mean, just look at this. On the left, you've got Dewdney's original pen and ink diagram. And on the right, a modern 3D printed version you can actually hold in your hand. It's the same beautiful, timeless idea, just brought to life over a century later, with technology he couldn't have dreamed of. So why does this puzzle stick around? Well, I think it's because it's so much more than just a puzzle. It's this perfect bridge between the cold logic of math and the pure beauty of art. It's an incredibly satisfying, hands-on tool for teaching geometry, especially for people who learn by seeing and touching. And when you play with it, you're literally connecting with this long history of human cleverness.
I mean, today you can go online and find the files to 3D print your very own Haberdasher's puzzle. A whole new generation is discovering it in classrooms, in makerspaces, and in living rooms around the world. It's bringing Dewdney's genius to life in a way he probably never could have imagined. And that really just leaves you with one final thought. If a perfect square can be hiding inside a perfect triangle, just waiting to be found with 4 simple cuts, it really makes you wonder, doesn't it? What other amazing bits of magic are hiding right in front of us, inside the simplest shapes we know?